Okay, so what we're doing is we're going to find the volume of a solid of revolution. Okay, same thing we've been doing, disk washer method. And it's between these two curves, but instead of revolving it around about the x or y axis, we're going to revolve it about the line y equals 5. So the first thing I'm going to do, just like you did on all of yours, is draw a picture of the area. And so y equals x cubed. If I put 1 in, I get 1. If I put 0 in, I get 0. But see, I know it's a curve, so if I put a number like 1/2 in, what's 1/2 cubed? 1/2 times 1/2 times 1/2, 1/8. Okay, so it's about there. So basically I know that this is y equals x cubed. Why am I stopping there? Because y equals x, the line, basically hits at 0, 0, 1, 1, 2, 2. This is, I know basically that this is right here, the section that I'm finding. That's the little section I'm going to rotate. Does that make sense? That's what I'm rotating. Okay, so this is y equals x cubed, and this is y equals x. And the line I'm going to revolve it around is the line that's way up here. Let's see, there's 1. I'm just going to put it just up here. We'll just call this y equals 5. I know it's not to scale, but just for purposes of seeing this, we're going to revolve it around, we're going to revolve this, instead of around the x or the y axis, we're going to revolve it around that line. So we're going to revolve it around that line, y equals 5. So instead of about the x-axis or the y-axis, we're going to revolve it about the line y equals 5, which is like an x-axis, isn't it? Okay, so this is where maybe the book's formula is a little better than the one I gave you, and the only difference is the book's formula for volume says this: pi times the capital R of x squared from a to b minus little r of x squared. And it's the same thing as f of x minus g of x, top minus bottom, but that could confuse you in a problem like this. Because if we take top minus bottom here, that's deceiving. Because is this the top function in relation to our line that we're revolving it around? No. And since the line is y equals 5 rather than y equals, what's the x-axis known as? Y equals 0. We have a little bit different thing to think about. When we were doing it around y equals x, it is the distance. The top function is the distance from that function to wherever we're revolving it around. That was your f of x, the top. We call it the outer radius because it's the one that's farthest away. It's the radius for the outer side of the shape if we're revolving it just around the x-axis. And this was the inner radius, or the bottom function. So if you think top minus bottom, that could make these about a different line a little more confusing. Instead of think of it as outer and inner radius. So this would be the outer, and this would be the inner function, outer and inner. Okay, and we have to think of that in relationship to what we're revolving it around. Okay, so this is not hard. I just have to think of how far is the distance from, would you agree that x cubed is the outer one? What is the distance from x cubed to 5? How far is that? This is going to be the function I write. I can't just put x cubed in there. I have to put what's the distance between x cubed and 5. Okay, so let's think about this. Once we get this thought about now, it's about the same for every problem, whether it's a horizontal or a vertical line we're revolving it around. Okay, so if I were revolving it around the x, what would the distance from there to there be? 5. But instead, I only want to go from 5 and stop right here. So what distance am I actually needing to get rid of? The distance between what and the x-axis? X cubed. So if this is 5, I need to take away the distance from x cubed. So the outer radius here, capital R of x, is 5 minus x cubed. Okay, so what's the inner radius? The one closest to the axis of rotation.
5 minus.
See, now the inner function is the x, right? So I would go 5, but I need to back up to there, so it's 5 minus x. And once you have it figured out that it's basically whatever line you're dealing with minus your function, it's pretty simple to set it up. Again, if I am wanting to find how far it is from here to here, that's my little r of x. Okay, if I were going all the way to the x-axis, it would be 5. But I only need from here to here, so this distance that I need to get rid of is x away, y equals x. So these are my two functions that I plug in. So I'm going to have to square 5 minus x cubed minus 5 minus x squared dx. And now I need to look at what are my limits of integration. 0 to 1. Always on the x-axis, okay? Y equals 5 is like an x-axis, so that area still goes from 0 to 1. You can still look on the x-axis to find your limits of integration, 0 to 1. Okay, so at this point, I can use, could I go through the work of foiling all these out and plugging it in? Or if you've got the graphing calculator, and Hannah, if you want to borrow one from my closet, you can borrow it indefinitely.
Okay.
Okay, so we're just going to plug it into our calculator now. Hit math 9, and then you can just type in the integral. The parentheses are going to be important. Yeah, well, and you can't use it for indefinite integral, so when you don't have limits of integration, you still have to work it all the way out, which is all of chapter 8 without limits of integration.
Wait, my calculator doesn't go.
Okay, so now let's look at another example. And this example is going to be about a vertical line. So we have kind of the same functions. So we're going to revolve, we're going to find the volume here. We've got y equals x cubed again, y equals 0, x equals 1, and this time we want to revolve it about the line x equals 2. So if I sketch my area here, x cubed we've already graphed. Basically it looks like this. The whole graph looks something like this. If you put 2 in, it's like way up at 8. It like shoots up like this. That's what the whole x cubed looks like. And then the other, now we don't have the line y equals x this time. We have y equals 0. This is y equals x cubed. And then x equals 1. So what is the little section that we're revolving? General shape of it. Triangle, right there. And we're going to revolve that about what line? Okay, so x equals 2 is right here. And this is what we're going to revolve it around. So we're going to revolve it around this. We're going to get that little shape. Okay, so when we're thinking about distance, so for the outer radius, the one farthest away, your f of x, top, but farthest away from your axis, which function is that? Okay, now, what am I thinking incorrectly here? Should it be r of x? We're revolving, what is this like revolving around? It's like revolving about the y-axis, so it should be an r of y and a little r of y. Because the formula for revolving volumes about the y-axis is pi times the integral from c to d of capital R of y squared, or f of y squared, minus little r of y squared, dy. It's the line x equals 2 is like a y-axis. So now we need everything in terms of y. So my outer radius function, instead of being y equals x cubed, should be what? X equals y to the 1/3 cube root of y. Okay, so the outer radius, now it's not just the cube root of y, we have to think of the distance. This distance, let me try to use a different color like black here. This distance right here, that is your capital R of y. Okay, so how far is our axis from here? 2, but I don't need it all the way, I need to get rid of that. So what do I need to subtract off? Cube root of y. So 2 minus the cube root of y, y to the 1/3, that's the outer radius. And what's the inner radius? Right here. Well, that's 2, right? Well, how far, isn't that just 2 minus 1? 1. 2 minus 1, or 1.
I didn't hear it.
So what's the main thing that's different between finding the volume about an x or y axis or finding it about a different line? Yeah, you have to subtract your function from the axis of rotation.
I don't see how you got 2 minus 1.
2 minus 1? Okay, so from the axis of rotation all the way to here is
Oh, okay.
2, and this is the cutoff. I need to back it up, and that's the line x equals 1. Does that make sense? Okay. All right, so now all I have to do, once I find these, I just plug them in. Question, Pablo?
Oh wait, never mind. I see how it works. No, I
Okay.
was wondering like what point do you choose for like the equation one to subtract it, but I realized that the equation covers all the numbers and you need that area. So.
Yep.
Got it.
Okay, so now let's set up our volume formula, pi times. Now we need to look on the y-axis to find our limits of integration. So 0 to 1. And then I need to square each of these. Well, 1 squared is 1, right?
Yeah. Yeah.
Okay. So I'll work this one out by hand. So this will be pi times the integral from 0 to 1. If I square this, I have to FOIL it. So that'll give me 4 minus 2y to the 1/3 minus another 2y to the 1/3 gives me minus 4y to the 1/3. And then negative y to the 1/3 times negative y to the 1/3 is positive y to the 2/3. Add the exponents. It's annoying. It's a drill, yes. Yep.
First time.
Okay.
First time I heard that noise on Phil Gray.
Like, why do they seriously do this during this?
Okay, let's stay focused here. Okay, so 4 minus 1, I'm just integrating 3 minus 4y to the 1/3 plus y to the 2/3 dy. Okay, antiderivative of 3. Antiderivative of 3. 3y. Minus antiderivative of 4y to the 1/3. Add 1 to the power, y to the 4/3. Multiply by the reciprocal, 3/4. What happens to the 4s? So you get 3. Add 1 to the exponent here, y to the 5/3 times 3/5 between 0 and 1. What's going to happen when I put 0 in? It's going to be 0. So if I just plug 1 in, what do you get? 3 minus 3 is 0. So 3 pi over 5 is your volume.